Bismillahirrahmanirrahim. Welcome to the Inclined Thinker. I am Sadiq Amar, your chemistry teacher. Respected listeners, आज हम केमिस्ट्री नाइन्थ का चैप्टर नंबर 5 का फर्स्ट पोर्शन जो है वो डिस्कस करने जा रहे हैं. द नेम ऑफ द चैप्टर इज फिजिकल स्टेट्स ऑफ द मैटर. इसके जो है वो टोटल 16 लेक्चर होंगे और उसके बाद हमारे पास 4 असेसमेंट पीरियड्स होंगे और एग्जामिनेशन में इसकी जो परसेंटेज है वो 10% होगी. इसमें जो हम मेजर कॉन्सेप्ट्स डिस्कस करेंगे वो है गैशियस स्टेट. उसमें हम उसकी टिपिकल प्रॉपर्टीज़ को डिस्कस करेंगे और उसके बाद लॉज रिलेटेड टू द गैसेस उसको डिस्कस करेंगे. उसके बाद जो है वो लिक्विड स्टेट है. लिक्विड स्टेट में हम टिपिकल प्रॉपर्टीज़ ऑफ द लिक्विड स्टेट को डिस्कस करेंगे. एंड द थर्ड वन एंड मोस्ट इम्पॉर्टेंट वन इज़ द सॉलिड स्टेट. इसमें हम 3 पॉइंट्स को डिस्कस करेंगे. एक है टिपिकल प्रॉपर्टीज, उसके बाद है टाइप्स ऑफ द सॉलिड्स और एलोट्रॉपी. द पॉइंट ऑफ डिस्कशंस टुडे इज इंट्रोडक्शन ऑफ द चैप्टर, डेफिनेशन ऑफ द गैस, लिक्विड एंड सॉलिड्स, डिफ्यूजन, effusion, pressure, standard atmospheric pressure, compressibility, mobility and density of the gases. First of all, in the context of the introduction, we are familiar that matters exist in the 4 different states like solid, liquid, gas and plasma. And gas is a very simplest form of the states of the matter, and it is the simplest form of the matter, and furthermore the liquids are less common as compared to the solids and as compared to the gases. Matter in the gaseous state does not have the definite shape and volume. This is related to the definition. Inshallah, we are in the next lectures we are going to study these definitions in detail. Therefore, gases occupies all the available spaces. Their molecular forces are very much weak as compared to the solids and the liquids, and furthermore the pressure is a significant property of the gases. In the context of the definition, first of all we will see the liquid. Liquid is basically a state of the matter which has the indefinite shape but definite volume. It means it has a fixed volume but its shape is not a fixed. It has a stronger intermolecular forces as compared to the gases and take the shape of the container in which they kept. Furthermore, it evaporates with the increase of the kinetic energy or with the increase of the temperature, and when vapors escape in the airs or strike with the wall of the container, they exert the pressure, and when the vapor pressure of the liquid becomes equal to the external pressure, then it boils. This is basically called the boiling points. Furthermore, liquids are less mobile than the gases, therefore they diffuse slowly. It's mean the diffusion depends upon the intermolecular distance within the molecules. If the intermolecular distance is greater, it means rate of diffusion is also a high. In the context of the solids, as the atoms in the solids are tightly packed with one another, it means they have fixed shape and fixed volume. So we can define it the state of matter which has definite shape and definite volume is called or are called liquids. Solids are very rigid and denser as compared to the liquids and the gases. They exist in the amorphous and the crystalline forms. Dear students, these are 2 famous types and important types of the solid. Those are called amorphous solids and the crystalline solids. Now we are going to discuss the typical properties of the gas. First of all, definitions of the diffusion. First property is diffusion. Diffusion is basically automatic or spontaneous mixing of the molecules, and this mixing depends upon the random motion and collision of the molecules for the formation of the homogeneous mixture, that is called diffusion. In other words, we can say flow of the material in the context of the gases or in the context of the liquids from the higher concentration to the lower concentration. As gases have the strong intermolecular distance or greater intermolecular distance, so they can diffuse very rapidly because their random motion is greater as compared to the liquids. So the important point is that the rate of the diffusion depends upon the molecular mass of the gases. So we can say that lighter gases have the greater rate of the diffusion as compared to the heavier gases. We can say that the rate of the diffusion depends upon the atomic mass of the gases. We are discussing the logical question that why hydrogen diffuse 4 times faster than the oxygen gas. It is very obvious we will have to find out the atomic mass of the molecules or atomic mass of the two gases, as we know that the atomic mass of the one hydrogen atom is 1. So the atomic mass of the hydrogen is 2, and furthermore the atomic mass of the oxygen, as one oxygen is equal to 16, so the atomic mass of the oxygen is 32. It's mean the atomic mass of the hydrogen is lesser than the atomic mass of the oxygen. So we can say that the rate of the diffusion of the hydrogen gas is much more faster as compared to the oxygen due to the low atomic mass. This is very important hint that has been described at the bottom of the slide, that diffusion is inversely proportional to the atomic mass. With the increase of the atomic mass, the rate of the diffusion will be low and vice versa. The next property is the property of the diffusion. First of all, we will see the example of the diffusion. These are two gases. One of them are shown by the blue color and other is shown by the red color. Randomly they are moving from the one place to another place, and as a context they will be mix with one another, and this process is called diffusion. In the context of the effusion is also depend upon the atomic mass. If the atomic mass is lesser, it means rate of diffusion will be high, but if the atomic mass is greater, the rate of the diffusion will be very low. Let's see the example. We have a box of a gas that is divided into the two parts, and if we see this white spot, it is basically a very small hole in which the atoms can pass uh, through this hole one by one. So we can say the escape of the molecules from a very narrow or tiny holes one by one is called effusion. Now we are going to the wording. It is the escape of the gas molecules through a tiny holes into a space with lesser pressure. Now we will see the examples as the tire is burst. This is a good example of the effusion. Furthermore, effusion depends upon the molecular mass. Lighter gases effuse very easily as compared to the heavy gases. Next one is the typical properties of the gases. Pressure is defined as force applying per unit area is called pressure. A kid pushing the air into the balloon is a best example of the pressure. In the context of the explanation, gas molecules are always in the continuous motion, that is called random motion. So when molecules strike with the wall of the container or any other surface, they exert the pressure. So pressure is equal to force over meter square. You can say pressure is equal to force over area. The pressure is equal to force over area, and the unit of the force is Newton, and the unit of the area is meter square. So the unit of the pressure is Newton per meter square. This Newton per meter square is equal to the Pascal. It's mean 1 Pascal is equal to the 1 Newton per meter square. And the other typical property of the gas is standard atmospheric pressure. First of all, keep it in mind that such types of the state exist at the sea level. This is very important, that the standard atmospheric pressure, when we are saying about this concept regarding the standard atmospheric pressure, it's mean we are saying something regarding the sea level. So we can define the pressure exerted by the mercury column of 760 mm of Hg at sea level is called standard atmospheric pressure. It is a sufficient pressure to support a column of the mercury 760 mm in a height at a sea level. So we can say that 1 atmospheric pressure is equal to 760 mm of Hg, that is equal to the 760 torr. So we can say that 101325 Newton meter is equal to 101325 Pascal, where 1 mm of He is equal to 1 torr. And the fifth one is the very important, that is called compressibility. Dear students, as we are familiar, there are the intermolecular distances among the atoms of the molecules. It means they have capacity to compress when applying the pressure. Let's see these examples. The distance in this container is greater than this and greater than this. It's mean there are greater intermolecular distance when pressure is lesser. When we apply the pressure from this to this, it's mean the intermolecular distance become lesser and molecules come close to each other. Furthermore, when we apply the further pressure, it's mean that intermolecular distance will remain very less, so they come close to each other. We are seeing another example. In this context, the intermolecular distance between the molecules or between the atoms of the gases are greater, and when we apply the pressure, this red arrow denoted that we are applying the pressure. It's mean the distance between the molecules of the gases become lesser and lesser and they come close to each other. This process is called compressibility. Basically, gases are compressible when pressure is applied upon it, because the distance between the molecules become lesser and lesser and the molecule come close to each other. The next property is the mobility. Mobility also depends upon the random motion and the intermolecular distance of the molecules. Therefore, the gas molecules always in the state of the continuous motion. Such type of motion is called random motion. They can move from one place to another place because gas molecules possessing very high kinetic energy. They move through the empty spaces and they are available for the molecules to move freely. This mobility or random motion results in mixing of the gas molecules to produce the homogeneous mixture. And seventh and the last one, the seventh typical property is the density of the gases. As we are familiar that density is equal to mass over volume. Mass applying per unit area is called density. Gases have low density than the liquids and the solids. It is due to the lighter mass and the more volume occupied by the gas. So the density of the gas is represented in gram per decimeter cube like this. And furthermore, the density of the liquid and solids are represented into the gram per centimeter cube like this. So the liquids and solids are 1000 times denser than the gases. The density of the gases increase by cooling because their volume decreases. In the context of the example, at the normal atmospheric pressure, the density of the gas or density of the oxygen gas is 1.4 gram per decimeter cube when the temperature is 20 degrees centigrade. But when the temperature is 0 degrees centigrade, the density of the oxygen gas will increase, that is 1.5 gram per decimeter cube. It's mean that with the cooling the molecules come close to each other and they become denser. So by the cooling the density of the gases will increase. Thank you very much students. I have also launched website for the inclined thinkers. You can also see your lectures. Thank you very much for watching.